think about replication, what we've just basically defined. What transaction would you have to do to get this cash flow here?
We need to buy 5 of this.
Yes, you buy 5 times this elementary security. Right? So the price of this thing then should be 5 times pi u, right? Because that's how you replicate this contract. Let's do another example. How about a weird cash flow of, say, plus 10, minus 10? What's the price of this related to the state prices? So how do I get the plus 10 up here? I buy 10 times of this, right? How do I get the 10? If there was a plus 10, how do I get this?
Short sale.
Yeah, so in this case, if it's a minus, I do a short sale, right? So I buy this 10 times and I sell this security 10 times. That gives me the same cash flow, right? So the price of this animal here is 10 times pi u minus 10 times pi d. Right. So once you know those two state prices, the only thing you have to do is you take the cash flow in the up state, multiply with the state price for that state, take the cash flow in the down state and multiply with the price of that state, and then you add this up. You can compute the value of any number, the present value of any number that I write down there, using those two state prices. And the interesting thing is that you don't have to worry about risk. I didn't mention the word probability here, right? I didn't mention kind of the risk profile. It doesn't matter here. If you know those two state prices, you can basically just multiply the cash flows with those two prices and add them up, and you're done. It's a pretty simple valuation method. The problem will, of course, will be how do we determine the state prices and how to interpret them. Right? So the determination part in a simple example will be your homework. Hopefully straightforward, and the interpretation will be something that we do next week. However, before you can solve it at home, I need to talk a little bit about this last security here. What is this? So this is a security, a new one, where you buy basically one of each state price security, right? So it gives you one in the up state and one in the down state. So if you have the same cash flow in all scenarios, how do we call such an asset?
Risk-free?
Yes, very good. It's risk-free, right? If it's the same cash flow in all the scenarios, there is no risk, right? Because you always get the same number, right? Something that we wrote down last week. So by doing this here, this here is going to be risk-free. And what I've written down here is the price of something that's risk-free. Well, it will be the cash flow 1 divided by 1 plus the risk-free rate raised to the time period. That's how we kind of just basically did the valuation of the bond and how we did present values last time. So this here is the price of a risk-free asset. Paying €1. In year T, the maturity date. And the left part here is kind of our replication strategy. It's the portfolio of those two state prices. How much do I have to pay for it? Well, the price for this plus the price for this. Right? So if you buy one of each state price security, the price of this portfolio should be equal to the price of the risk-free asset. So this is my replicating portfolio. Better speaking, is the price of my replicating portfolio. So the state prices are related to the risk-free rate, right? The sum of all state prices is basically 1 over 1 plus the risk-free rate. Typically, if rates are positive, then this number will be a number smaller than 1, right? So 1 divided by 1 plus something positive is usually giving you a number of 0.9 or something, 0.95. So the sum of all state prices is below 1, basically. questions regarding those definitions? Well, at this point, we haven't interpreted anything. I've just given you the definitions of elementary securities. I briefly showed you what the application is. It's actually, I have some more examples in the slides, so if this here on top was too short, we'll come back to this next week.
Won't bring it to zero if you're buying 10 times if you're buying.
Yeah, so that's a very good point. So the two prices that you see here, they're not necessarily equal. And we'll actually going to develop a rationale for why one might be higher than the other. Right, so think about this in economic terms, why that might be the case. Right, and that's a really important discussion that we need to have, and we should take a little bit more time than we have today for this. So maybe it will be kind of 30 minutes, 1 hour at the beginning of next lecture. Because the intuition behind the price difference will be the intuition behind any asset pricing theory in the world. Because that's exactly about it. Question which is good and which is bad, and what's the value of a payment in a good scenario and a bad scenario. That's the key of asset pricing theory. So if you understand this little toy example here, of course it's not realistic, right? So we have more than 2 states and more than one time period. But if you understand the logic behind this, you will understand every asset pricing theory in the world, because the mechanism is always the same as in this example. Right? So now I'm going to motivate a risk measure based on this example as well. So if you've heard about the beta, the capital market beta, it's a motivating example for why we need the beta in the first place. Right? To give it a preview, it helps us to identify good and bad states. That's the purpose of the beta. Now, let me come to the point that I would like you to do as a homework. So, you have the following pieces of information. Well, we have the setting where we have a one-period economy, so the 1 year. There are 2 scenarios or states. We don't know the probability of the scenarios. We also don't know the risk preferences of the investors. We also don't know any discount rate. We don't know the rate for discounting, we don't know risk preferences, we don't know risk premium, we don't know nothing. We don't even know the probabilities of the 2 scenarios. The only information that we have is, we know what the risk-free interest rate is. It's 11.11% per year. And we observe this traded security here, which has this stream of cash flows. It has a price today of 136. It pays you 237 in the upstate and 83 in the downstate. And your task for next week is to use this information to back out the state prices. Right, so we do a reverse calculation. So state prices are calculated based on observable market information. These 2 pieces of information are not enough. A risky security and a risk-free security. And prices and numbers, which I wrote down here, are sufficient to write down these 2 state prices. Right? So the question is, determine pi u and determine pi b, the 2 state prices, given these numbers here. Right, so I have this little box here where I'm going to fill in the solution for next week together with you. It will require a little bit of math, but it's not kind of difficult math, so no derivatives or anything. It's just plus, minus, multiply, and so on. So you should be able to solve it. So basically what you will do here, technically speaking, is you have a system of 2 equations with 2 unknown variables. That's something that you should be able to solve using high school math, hopefully. Right? So 2 unknowns can be derived using 2 conditions. So you have to figure out what are the 2 conditions that you can use. So you start with 2 equations, and then you solve for pi u and pi b in that system of equations. So if you want to think ahead, you can already apply this now to the next example. But we can also do this together next week. So you have another security, which gives you 83 and 237 in the downstate. The question is, what's the price of this security? So you have to use the state prices, which you backed out of the other information, and price to compute the value of this security. Let me just add this here, maybe. So that should give you enough practice with this. So highlight the relevance again. So this will be a motivation for capital asset pricing model. But this is basically also the way how option pricing works, right? So we come back to this technique when we want to compute stock options later in the class. So even though this might look overly simplistic, it is an important theory that has many applications. Okay, so I know this is usually a little bit challenging because I just throw this notation at you. Do you have any questions that you would like to clarify before you try yourself on the homework? Good. So then you should have everything to get a go at this. And if there are no further questions, let's call it a day. And see you next week.